This is the explanation of the problem about the trees that was due on Tuesday night. It was a growth of a tree, and there was a table that was given to you, and then also in part D you were given a function. Now in the first one we can't know the exact derivative at 6, so that's why we use 7 and 5. A little bit to the right of 6 and a little bit to the left of 6. And so we get 5 over 2. Now, this is in meters per year, and so we can approximate the rate of change at 6 by using 7 and 5. So this is actually an average rate of change, but we're using that to approximate an instantaneous rate of change. Notice that you get 1 point for the estimate and 1 point for the interpretation of the units. Now in part B, you'll notice right away that there was a typo on the exam. This should be over the interval from 3 to 5 instead of 2 to 10. And I changed that in class, but you might not have noticed it in the homework. But here's the mean value theorem showing up again. This is our average rate of change. And the mean value theorem states that if the function is differentiable on this interval, okay, we also know it's continuous then. And then by the mean value theorem, there is going to be a value on that interval where the instantaneous rate of change is equal to the average rate of change that you calculated here. So this mean value theorem, very, very important. Differentiable, continuous, there's going to be a value on that interval where the instantaneous is equal to the average rate of change. Now in part C, we're asked for the average height, and here's a formula for the average height. But then they ask us to use the trapezoidal rule to estimate this integral. So here we have the 1/8. And then now we're using the trapezoidal rule here. Now the only thing I'd like to point out that this is the change in x divided by 2. Change in x divided by 2. Change in x divided by 2. So the answer is written up a little bit differently than what I do in class. I take the interval divided by 2, and then I take the left and the right. The left and the right. They have written it a little bit differently, but it turns out to be the same. And then when we find the average height, we get 263 over 32 meters. And you want to say what that is in terms of the average rate of change. I'm sorry, the average height here. It's not an average rate of change, it's an average height. So that's why we say meters here. Now, in letter D, we are given these values when the diameter, when given the diameter, and this is at a height of 50 feet. Okay. Now, it gives us the rate at which the diameter is increasing. Okay, the diameter of the base is increasing at this rate per year. Notice we're using the quotient rule. And then we have the dx dt. So this is really a related rate problem. We're given this dx dt, which is 0.03. And so then when we plug in the values at the designated heights, then we can get 3/4. Okay? So the rate of change of the height of the tree with respect to time when it is 50 meters tall is 3/4 meters per year. So what we have here is the quotient rule, and then the dx dt. This dx dt here is the value that we're given, and this is because of the chain rule. Okay.